Hello, viewers. In today's session, we are going to discuss another important problem from definite integrals, in which we'll discuss this problem using the concept of Leibniz integral rule. So here we are given a function f of x that is equal to the integral 1 over x to 2 over x, and the integrand is a function of x and t, that is cosine xt divided by t dt, and we have to find the derivative of this function f of x with respect to x, right? So here we'll find out the derivative of this integral using the concept of Leibniz integral rule, right? So Leibniz integral rule help us to find out the derivative of an integral where the limits of integration are some function of x, right? So let us first quickly see the statement of Leibniz integral rule, and then we can easily see that how we can find out the derivative of this integral. Now consider the integral where the lower limit and the upper limit are some function of x. Suppose the lower limit is u of x and the upper limit is v of x, and our integrand is a function of say x and t, right? And if we wish to find out the derivative of this integral with respect to x, then Leibniz integral rule says that first we'll write f of x comma v of x, that is first we'll replace this t by this upper limit v of x, then we multiply this quantity with the derivative of v of x, that is v prime of x, then we take a negative sign, and then we write f of x comma u of x, that is this time we'll replace this t by the lower limit, that is u of x, and then we'll multiply this quantity with the derivative of u of x, that is u prime of x, and then here we'll write a positive sign, and the integral u of x to v of x, and we take the partial derivative of this function with respect to x, that is we'll write del of del x, and here we have f of x comma t and dt. So this is the Leibniz integral rule, and let us see how we can apply this rule to get the derivative of this integral. So we'll write now d by dx, and here for this integral we have this one, so we have 1 over x to 2 over x cosine xt divided by t dt, and if we compare this integral with this one, then u of x is 1 over x, v of x is 2 over x, and f of x comma t is given by cos xt divided by t, right? And since we are differentiating both sides, so here we have d by dx of f of x. So taking the derivative of both sides, we have d by dx of f of x is equal to d by dx of this integral, right? So now we have f of x comma v of x, that is replacing this t by 2 by x. So we have cos of x times 2 over x, and here we have 2 over x, and then we take the derivative, that is v prime of x, and v prime of x is 2 by x. So here we have d by dx of 2 over x, then we have minus, and f of x comma u of x. So now I will replace these t's by 1 over x. So we have cos x times 1 over x divided by 1 over x, and here we have d by dx of 1 over x, and then we write the positive sign and the integral of 1 over x to 2 over x, and the partial derivative of the function, this function, that is cos of xt over t, and here we have dt. So let us now simplify. Here x and x get cancelled, and we have x over 2 taking x to the numerator, and here we have simply cos of 2, and then we have 2 times the derivative of 1 over x. So the derivative of 1 over x is negative 1 over x square. So here we have minus 1 over x square, and here x and x get cancelled, so we have cos of 1, and taking this x to the numerator we have x over 1, and here we have the derivative of 1 over x as minus 1 over x square, and then we have the integral of 1 over x to 2 over x, and the partial derivative of cos xt over t, right? So here we'll treat this t as a constant, so the derivative of cos xt is minus t sine xt, right? By chain rule, the derivative of xt with respect to x is simply t, and the derivative of cosine xt is negative sine xt, and this t remains as such because here we are taking the partial derivative with respect to x, and then we have dt. So now this x and this x get cancelled, this 2 and 2 get cancelled, so we are left with minus cosine 2 divided by x, because here we are left with 1x, and here minus and minus becomes plus, and this x and this x get cancelled, so we have cos 1 over x, right? And here this t and this t get cancelled, and we have negative, and 1 over x to 2 over x, and sine xt and dt. So now let us integrate sine xt with respect to t, right? So we have minus cos of 2 over x plus cos of 1 over x minus, now the integral of sine xt with respect to t is given by minus cosine xt divided by x, and the limits of integration are from 1 over x to 2 over x. So now we can write minus cos of 2 over x, and here we have cos of 1 over x. This negative and this negative get cancelled, that is when we multiply these two negatives we get positive, and we have 1 over x, and then we have cos of xt, and limits of integration are from 1 over x to 2 over x. So now we have minus cos of 2 over x plus cos of 1 over x, and here we have 1 over x, and now substituting the limits and taking the difference, first we'll take t is equal to 2 over x, so we have cos x times 2 over x minus cos of x times 1 over x, and now we can simplify it. We have minus cos 2 over x plus cos of 1 over x plus here x and x get cancelled, so we have simply cos of 2 minus here x and x get cancelled, so we have cos of 1. So now we have minus cos of 2 over x plus cos of 1 over x plus multiplying these two quantities by 1 over x, we have cos 2 over x minus cos 1 over x, right? And we can now easily see that this term and this term get cancelled, and this term and this term get cancelled. So we have here 0, right? So the derivative of this function f of x, that is f prime of x, is equal to 0, right? So viewers, the derivative of this function or this integral with respect to x using Leibniz integral rule is equal to 0. So now from this equation, this is a differential equation, and we can easily conclude that when the derivative of f of x is 0, then this implies that the function f of x is a constant function, right? Because the derivative of a constant function is 0, so the our function f of x is a constant function. So f prime of x is equal to 0 gives us f of x is equal to a constant. So this is how by making use of the concept of Leibniz integral rule, we can easily find out the derivative of these kind of integrals.